Hello, and welcome to everyone attending today's first webcast of the year, High-Tech Hands-On Learning with a Marble-Powered Computer, brought to you by Library Journal and the Library Corporation. My name is Rebecca Joswick, and I will be your moderator. But before we go further, I just have a few housekeeping items to run through with you. If you are experiencing technical problems, please use the Q&A window on the audience console, and I will get to you as soon as possible with a resolution. If you have questions or comments for the presenters, and I sure hope you do, you can also send those in at any time via the Q&A window. Our speakers today are anxious to hear from you. We will save some time at the end of today's webcast to address your questions. And if we don't get to yours, you can expect a follow-up via email. If your screen becomes locked due to local network congestion or some bandwidth issues, please try using F5 to refresh the webcast console. If you're on a Mac, use Command-R. Today's slide presentation is available for download in the green resources folder on the bottom menu dock. You may need to scroll to see that depending on the size of your screen. You can also find a certificate for continuing education credit in the resources folder. It's labeled certificate. There's also a cool Makerspace resource from TLC. You might want to check that out. Please join the conversation on Twitter. You can tweet us at Library Journal or with the hashtag LJTLC. And now I'm pleased to introduce today's speakers. We have Paul and Alyssa Boswell. They're the creators of Turing Tumble, a really cool, innovative learning tool designed to teach the fundamentals of computing in a hands-on way. It's really neat. And we have Rhea Stark, STEM specialist at TLC. And with that, I'm going to turn over the presentation. Go ahead.
Hey, this is Rhea. I want to start by introducing TLC SmartTech as the Library Corporation's newest product line for emerging STEM or STEAM and AV technologies, which also includes the supporting curriculum and services as well. TLC is proud to offer technology to give your makerspace that extra spark by providing extensive kits and technology like the ones listed here to promote hands-on learning in library and classroom makerspaces. We recognize a shift in the role libraries play in their community and the STEM focus in educators' classrooms. So we've cultivated a selection of premium brands which encourage creative thinking, problem-solving skills, and the ability to successfully strategize with others. And today, TLC SmartTech is excited to showcase the Turing Tumble. The Turing Tumble is, as Rebecca mentioned, a mechanical computer powered by marbles. It teaches the fundamentals of computer logic, and using the detachable, movable pieces like the ones on the screen, the Turing Tumble is a fun way to discover how computers really work. So like counting in binary, adding, subtracting, pattern creation, and so much more. If the Turing Tumble sounds familiar to you, it may be that you're remembering Alan Turing, the famous computer scientist, mathematician, cryptanalyst who notably invented the Turing machine to crack the Enigma code during World War II. Or in popular culture, you may know Alan Turing as Benedict Cumberbatch in The Imitation Game. The Turing Tumble was named after Alan Turing, and as its namesake suggests, it is Turing complete. This means that using the same gameplay and the same pieces on a much larger board, it can do anything that a real computer can do. Maybe you also recognize the Turing Tumble from its recent Kickstarter campaign. Kickstarter is an all-or-nothing crowdfunding site. Anyone can submit a project idea, and users pledge money to the projects they like. If the project reaches its goal, the Kickstarter was a success, and the creators are able to launch their project. But if the Kickstarter doesn't reach its goal, the backers get to keep their money. So Paul and Alyssa needed $48,000 to successfully fund the Turing Tumble project. And they received an impressive $400,000 from over 4,000 backers, and myself included. As an early backer, I was really excited to see that this project was funded and that I could own my very own Turing Tumble one day. And it's not just funded, it was 841% funded. So you can see the Kickstarter user base was extremely excited for the prospect of gaming on a mechanical computer and learning computer programming and logic in a fun, tactile sort of a way. And it's not just the Kickstarter market. I hope that by the end of this webinar, every school, every library will see the value in what the Turing Tumble can do and how they can implement it in their own makerspaces and their own classrooms. So being able to see the value of the Turing Tumble does goes hand in hand with the value of computer science education in general. STEM education and computer science skills, as we all know, are becoming more and more necessary in today's ever-changing world and digital-based job market. As jobs become more reliant on STEM fields, it just makes sense to prepare today's students for the jobs of the future. In 2016, the National Science Foundation and the U.S. Department of Education made a push for increasing computer science education in schools across America with the Computer Science for All initiative. And at his 2016 State of the Union address, former President Obama stated that in the coming years, we should build on that progress by offering every student the hands-on computer science and math classes that make them job-ready on day one. So what's great about this initiative, besides the national recognition of computer science and job-ready learning, is that it has gained traction across the country, and we're seeing more and more scholarships for STEM-related fields and more grants available to educators to alleviate some of the barriers of access. So while there are plenty of products in the world right now that introduce coding concepts and make computer logic fun to learn, the Turing Tumble is unique in its approach. Not only does it teach what the computational logic is, it actually shows how the logic works. So rather than focusing on coding syntax, which is another barrier of access to computer science, it removes the computer from the mysterious black box concept and exposes the mechanics and the foundation. And it does it without electricity, without batteries, without plugs. That alone makes it a great addition to any classroom or makerspace, but there is definitely more to it. Not only does the Turing Tumble really hit home on the computer science aspect, but it also can be combined with other curriculum models for more cross-functional STEM education. One of my personal favorite parts about the Turing Tumble, and there are a lot to choose from, is the fact that it can be entirely 3D printed. So the earliest versions of the pieces actually were 3D printed as Paul and Alyssa worked through different iterations, and you'll see that later in the webinar. So there's this virtual pack that's associated with it, and that includes all of the CAD files that are needed to recreate the Turing Tumble at home. And this provides an opportunity to learn more about how the Turing Tumble was created in the first place from an engineering standpoint, as well as the opportunity to learn more about 3D printing. So both of which go beyond the basics of computer science and really round out more of the STEM and maker aspects as a whole. Also, the Turing Tumble comes with over 60 story-based problems to solve, which makes this ideal for self-paced, independent learning, either for your breakout STEM time in your classroom or for passive programming in your library. You can just set it up and watch people come and learn how to use it. The Turing Tumble is really makerspace ready in a lot of different ways. It fits with national standards and initiatives, it has the curriculum element included, and it all comes in one compact box. It's extremely portable, and a few students can work on it together on one Turing Tumble at the same time. And once your students or your patrons have completed all of the puzzles, or even if they get stuck along the way, there's an online community where you can go look for new content as well as tips to get through some of the trickier levels. So obviously, I think this product makes sense on a large scale and that you could do a whole lesson plan around the Turing Tumble as a whole. I think every student would love to have their own. But I do also want to take a second to mention for some of the library or classroom makerspaces who are either just getting started or who maybe are in the process of getting grants but just aren't quite there yet and who aren't able to buy one for every student in the district, that it's okay to start small and just get enough to try it out. Because of the portable and collaborative nature of the Turing Tumble, it does work really well to add them to your internal maker rotation so other libraries or schools in your area can book them for their own programs. And it makes sense to incorporate them as their own STEM stations if you're doing maker days or STEM days so that as students rotate around the room, they can spend some time working on the Turing Tumble. It really does fit in nicely alongside other computer science curriculum with CAD education and design, with 3D printing projects, and definitely in your math classes. So with all that in mind, I will hand it over to Paul and Alyssa to actually show you what the Turing Tumble looks like in action, and maybe you can think of even more ways to incorporate it into your library or into your classroom.
Thanks so much, Ria. This is Alyssa.
And I'm Paul.
And we're really happy you all logged in for this webinar. We're really excited to tell you about Turing Tumble. We wanted to start with the inspiration for the product because there's this big disconnect between how much our kids use computers for entertainment and learning and just how little any of us know about how they actually work. And we all know that computers are everywhere. This is a picture of our kitchen while we were preparing this presentation. We want you to check out all the computers that are just in one room of our house. We have a couple laptops, the ice water dispenser in the fridge, a cell phone, dishwasher, microwave controls, oven controls, a Keurig, a tablet, and the most important one for me, the Instant Pot. We all rely on computers for so much of our lives now, both for work and play.
Yeah, when I was a professor at the University of Minnesota, I saw the need to have solid computer skills growing and growing, and not just for programming jobs, but for a wide range of professions. Biologists are writing macros in Excel to synthesize their data. Marketers need to code to create ads and analyze what's happening on online channels. Even creative professionals use programming to create works of art. Having a solid understanding of computers has become a valuable asset in a wide range of fields. But despite computers being everywhere, very few of us, adults included, really understand how they work.
Of course, that's not our fault. Technology has advanced tremendously over a time, and as a result, it has shrunk down to these amazingly high-powered computers that can fit in our pockets. Even when computers filled rooms, most people didn't understand how they work. And now we have these tiny computer chips with layers of complexity. You might have heard that computers are made up of a whole bunch of little switches or transistors. But how on earth do a bunch of switches do anything besides turn things on and off? We've come to accept that some magic is happening inside those little computer chips. This is unfortunate because we want our kids and our students to be curious about the things around them and to have a desire to learn how they work. We want them to take things apart, to learn how they function and see what's inside. But one of the most valuable, most common things around them is just too complicated to understand. We can teach students how to use computers. We can even teach them how to code them, but we can't teach them how they work. Imagine if kids had a solid understanding of how computers work, or maybe even just a clearer idea of what's going on inside that black box. Think of the confidence it would give them when they are learning to use Excel or troubleshooting a hard drive problem.
And it's not just about the kids. The way computers work is absolutely brilliant. It's something everyone should be exposed to. The concepts are interesting and accessible to both kids and adults, and they apply in a lot of other areas. I spent a lot of time teaching students programming and electronics, and when I had 3 kids of my own, I started looking around for toys that teach these concepts. So I got robot turtles when that came out, and we do a lot of Lego Mindstorms. We just got done with first Lego League. We coach a team, and we've tried Scratch and Bloxels, and our 3-year-old just got a Codapillar for Christmas. And they're all valuable tools for teaching computational thinking, but they all treat computers like abstract black boxes. They teach how the computers behave, but they don't teach how the computers work. They overlook the fundamental, most interesting concept of all, how simple switches connected together in clever ways can do incredibly smart things. While I was at the U, I began working on a toy to teach kids how computers work at their most basic level. I built a lot of prototypes and eventually arrived at a game where kids build their own computers. They don't build them from hard drives or motherboards, they build them from the most basic components of all, switches. And they don't use electricity to run the computers either. They use marbles. In fact, there's no electricity at all. So here's a video Alyssa and I made recently that gives a little introduction to it.
Introducing Turing Tumble, a completely new type of game where kids build mechanical computers powered by marbles to solve logic puzzles. Use ramps, crossovers, bits, interceptors, gears, and gear bits to build mechanical computers that can generate patterns, do logic, add, subtract, multiply, divide, and more. As a computer, its capabilities are limited only by the size of the board.
In the puzzle book, players become Aaliyah, a deep space engineer who crash lands on a forgotten planet and must solve a series of 60 puzzles to escape. The puzzles lead the player through a series of discoveries while they build critical thinking and raw coding skill. Kids learn best when they can use their senses to explore new concepts. Turing Tumble lets kids see and feel how computers work.
And adults, this game is not just for kids. Even if you're an expert programmer, we guarantee you'll find the ladder puzzles a formidable challenge.
Order your own copy of Turing Tumble and discover how simple switches, connected together in clever ways, can do incredibly smart things.
All right, so what excites us about Turing Tumble is that it provides a way to peek under the hood of computers. The logic isn't hidden inside a computer chip, it's all just right there in front of you. By placing simple plastic parts onto a mechanical computer board, you can build your own marble-powered computers.
You saw the parts of the game in the video, but I wanted to show a picture of everything that comes with it. As you can see, you get more than enough parts to build some really cool computers and plenty of marbles, because we know those are all going to roll all over the place. I also want you to notice that the puzzle book has 60 puzzles, as well as a comic book story woven into it. And it's beautifully illustrated by Xiaoyang Li. She actually started creating the comics while she was a student at the University of Minnesota. Now I'm going to lead you through one of the puzzles to show you how the game works. First of all, you select a puzzle. The puzzles start easy and grow more and more difficult. It's a good idea to start at the beginning and not skip puzzles because the concepts build on each other. The goal of each puzzle is to build a computer that completes an objective. For example, this shows Challenge 1. You can see there's a page of the book right there, and at the top it says Challenge 1. This one's called Gravity. The objective of this puzzle is to make all the blue balls, and only the blue balls, reach the end. You can see underneath the challenge there's the objective, then there's the required output. Then what you're going to do is you're going to build the starting setup. Many of the puzzles require parts to be placed in certain positions to begin. For this puzzle, the starting setup looks like this once it's built. You can see there are 6 green ramps that are placed on the board. Then you need to plan your solution. Your job is to figure out where to put the available parts in order to complete the objective. It tells you that you have 4 green ramps to add to the board, but where should you put them? If you just run the board with the starting setup, this is what's going to happen. As you can see, the balls are jumping all over. The blue balls are triggering the ball release on the red side, and it's not working at all. You have all sorts of different marbles that are at the end. And remember, the objective is to get only blue balls at the end. So to solve this puzzle, you need to place the 4 ramps in such a way that they complete the path from the top of the board to the bottom of the board. Here it is running. As you can see now, all the ramps are placed in a position to guide the blue balls down. Every time the blue ball release is triggered, it releases another blue ball. It works perfectly. So this puzzle is really simple. It's puzzle 1. And it didn't use any smart logic like a computer. So now we're going to show you some examples of computers built from this Turing Tumble that are a little more complicated.
Okay, so here's a little computer that generates a pattern. In this case, it generates the pattern blue, 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 red, blue, 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 red, blue, blue, blue. So 3 blues and a red. And so we'll show it running here quickly. All right. So getting a pattern of 3 in a row is actually pretty tricky. And here we use year bits to solve the problem. So you see 2 blue balls fell. Now the third one is going to release a red ball. That's how we get our red ball. And that one's going to release a blue ball. And it's going to release 2 more blue balls after this. Get 3 in a row. And then it's back to another red ball. And it'll continue this way until the balls run out on top.
Pretty cool.
Okay, so that was just a pattern generator. It still didn't really show how it's a computer exactly. But this will help. So when you get to puzzle 21, the concept of binary is introduced. Now, binary seems kind of complicated, but it's actually pretty simple. It's just a way of representing numbers with on and off switches. So on the left side is a column with 4 switches. Together they represent a number. Now, before you can read the number there, you need to remember that the top switch is worth 1, the second switch is worth 2, the third switch is worth 4, and the bottom switch is worth 8. So from top to bottom, that's 1, 2, 4, and then 8. Now, when you're figuring out the numbers shown by the switches, you add together the value of the switches that are pointed to the right. You don't add the switches that are pointed left. If a switch is pointed right, you add it to the total, and if a switch is pointed left, you don't add it. So, the column of switches on the left is 0, because all the switches are pointed left. Now, in the second column there, the value is 1, because only the switch representing 1 is pointed right. In the third column there, only the third switch is pointed to the right. Now, if you remember, that switch has a value of 4, so the number represented by the switches is 4. And then in the next column over, you see that the top switch and the third switch are both pointed to the right. So that's 1 plus 4 equals 5, right? And then the last one there, you have the 1 place, the 2's place, and the 4's place all pointed right. So you add those together to get 7. 1 plus 2 plus 4 is 7. All right, now I'm going to show you a computer that counts to 8 in binary and then stops itself. All right, here it goes. All right, so if you look quickly, you could see all of the switches started at 0, and the first ball made them point to 1. Now this ball is pointing to, say, 6. 1 plus 2 is 3. Now the 4's place is to the right, so it equals 4. 1 plus 4 is 5. 2 plus 4 is 6. 1 plus 2 plus 4 is 7. And this last ball is going to stop after changing it to 8. There we go. All right. Now, I want to show you one more time that video because it went really fast. Let's do it one more time. So remember, they all start pointed to the left. So they say 0. All right. Now the first ball changes it to 1. If you remember, it's 1, 2, 4, and 8 there. So now the 2's place is pointed right. So that's 2. 1 plus 2 is 3. And now it's 4. 1 plus 4 is 5. 2 plus 4 is 6. And 1 plus 2 plus 4 is 7. And finally, we have 8. All right. Let's keep going here. So now this is a computer that is from the last half of the book. So this builds on that puzzle. And here we're actually going to add two numbers together. We add the numbers shown by the column of switches on the left to the numbers shown by the column of switches on the right. So here, you can't see it yet, but it's going to start, when the video starts, the left switches are going to start with a value of 5. So the 1's place and the 4's place are going to be pointed right. And the right switches are going to start with a value of 6. All right, let's watch it go. After it runs, you'll see that the switches on the right point to 11. Now, the video stops really fast, so you'll have to count up that 11 just as the last ball turns it that way. Now, the way it's actually adding the two numbers is each ball that goes down, the blue ball subtracts 1 from the left side, and each red ball that goes down adds 1 to the right side. That's how it adds those two numbers together. Alright, when it stops here, there'll be 1 red ball. Okay, now it's pointing 11 on the right side, and then this last ball will stop the computer. Alright, so, at a basic level, Turing Tumble is a fun logic puzzle and a cool marble run, accessible to anyone, but it can also be used to dive really, really deep. It's actually its own programming language and sort of blurs the line between building and coding. Normally when you teach coding, you start with a steep barrier of having to first teach language syntax. You have to get your semicolons in the right places. You have to capitalize correctly and put your tabs in just the right spots, or your program won't work.
Even in graphical languages like Scratch or Lego Mindstorms, there's still a significant barrier there to learning the interface. It's really hard for kids to get it right at the same time as they're trying to learn the underlying logic of programming. And it takes a significant amount of time before a student can be comfortable enough with the language itself that they can begin to sit back and focus on the part we really want them to learn, the logic of the programming.
Yeah, and I think a really cool thing about Turing Tumble is that you don't have that barrier. It's extremely intuitive. You define your program simply by where you place the parts on the board. Students quickly get to the point that they build those logic and critical thinking skills, raw coding concepts, and at the same time it grounds their understanding of computers. And when you get further, the game teaches important concepts like binary. So if you've ever wondered why computers use binary to represent numbers and not the regular base 10 system, you quickly learn why about midway through the puzzles. Reading why in a book is so different than experiencing it. You'll never forget why after building your own binary counter. Students taking computer science classes will also recognize that they're creating logic operations like AND, OR, NOR, NAND, or exclusive OR. And don't worry if you don't understand any of those terms. We avoid the terms in the book. Students work through the puzzles one by one and find themselves building those things on their own. And when they get further, they'll learn how binary operations are done. They'll learn how to add binary numbers together, subtract them, multiply them, divide them. You learn how to detect when a number is odd or even, to test if one number is greater than another. And finally, you learn how to build all the fundamental components of a computer processor.
As a teacher myself, I'm really excited about the application of Turing Tumble in the classroom and in libraries. It's been said before, but the best thing about this is that you don't have to update any programs. You don't even have to plug it in. All you have to do is pull it out of the box and it's ready to go. This is an ideal STEM-based learning tool. There's also individual self-guided learning built in. The puzzle book that comes with it is fun, addictive, and easy to follow for ages 8 and up. Younger students enjoy it too. We have a 6-year-old at home and he loves it. But he just needs a little more guidance because of the reading level of the book. It's also great in libraries and schools because you can use it with a small group. You can use it with a small group. Ideally, you have 1 to 2 students on a board at a time. Because of the nature of this tool, students need to accomplish and understand each level themselves. The skills build with each page. We've had adults try to skip to the middle of the book, and then they've actually gotten stuck because they haven't gone through the process of learning how each part works and how each part works with the other pieces. There's natural scaffolding if you follow the guide. We're also going to be adding more puzzles online that will be free to download. The book will reference these additional puzzles so that if you or your student get stuck on a particular puzzle, you can get extra practice on similar skills with the online puzzles and then continue on in the book. It's great in classes, in a traditional class setting, a library class that might be offered for a month or more, or incorporated into current class offerings. The great thing about using Turing Tumble with a class full of students is that they can all work at their own pace. If the teacher works through a few puzzles on his or her own, it's really easy to describe the approach to the students and then cut them loose to just play, have fun, and learn on their own. It's great for STEM programs, STEM nights, or free play STEM stations. We've had the chance to attend a handful of STEM events in our area, and it's always a big hit with the kids. They're able to pick up on the puzzle book quickly with just a few short directions, and they really enjoy seeing how far they can get. Usually the parents are the ones urging them to move on to the next activity.
Turing Tumble is also a great partner for your 3D printer. Not only were all the initial prototypes created on a 3D printer, but there's already a growing community that's trailblazing ways to print the game at a home or library. On higher-end 3D printers with a big build platform, it's no problem to print all the parts for Turing Tumble. On the other hand, we thought it might be a challenge to print the computer board on a low-cost 3D printer because the board's so big, but we already have an enthusiast who's broken the board up into smaller pieces that can be printed separately. And he's actually posted the files for it on the community forums.
Before we wrap up, I just want to point out a couple of online resources to you. We recently launched our website, turingtumble.com, and we have a page on there for educators. The content of this page is in development, and even though the puzzle book that comes with the game makes it easy to use immediately, we'd like to work toward more resources that will help teachers tie the game concepts to specific units, classroom goals, and school-wide STEM or STEAM efforts. And also, as we mentioned, there's this great community page that's already active with people sharing about their 3D printing of the game and its parts. This page also has hints for puzzles that are tricky and an invitation for people to share their puzzle solutions with others. Thanks so much for joining us today. Our local library and district librarians have been enthusiastic supporters of Turing Tumble, and we're so grateful that we had the chance to talk to all of you today. We're really looking forward to answering the questions that are coming in and being able to see how we can help you use Turing Tumble in your schools and libraries.
Yeah, thanks for listening.
Thanks so much, Paul, Alyssa, and Maria. We do have a few really great questions from the audience. Before I launch into those, I will just share a comment. Kate from McAllen Public Library says, "That looks awesome."
Thanks, Kate.
Well done. I have to agree. It's an ingenious way to teach those fundamentals that are so often left out from basic coding and programming classes. I have another question. I know, Alyssa, you mentioned on one slide that this is for, generally speaking, ages 8 and up, and that with some guidance, possibly a little bit younger. But would you consider this something for all age groups, even maybe secondary school or high schoolers?
Yeah, I definitely think it's great for middle school and high school. We were at our local Maker Fair just this last summer, and I had middle school and high school kids come up that had taken some of the early computer programming classes, and they watched the video that we had playing, and they watched the game board and other people messing with it. And when it was their turn, they would say, "I get it, that's like an AND gate. I learned about that in my class." And it was a really neat way for them to connect something to what they were learning, that's something that's tangible that they can mess with.
Okay, cool. And kind of to that same point, Paul, Alyssa, Ray, you might want to weigh in on this one as well. What about the learning curve for teachers and librarians? Do you find that they can kind of easily grasp how to best facilitate and help their students get the gist of how to go through the puzzles and games?
Yeah, I would say so. I've tried a lot of stuff with my kids, and a lot of them take some time to figure out how to get going on them before you can really have your kids start, because you really have to, work with them. So, for instance, with Scratch, I couldn't just let my fourth grader just have at it, because it kind of needed some introduction. And with Lego Mindstorms, it's kind of the same thing. You have to set the computer up and install the software, and there's a lot of steps that you need to go through beforehand. I think one of the great things about this is that it really is something that, if your kid knows how to read, it's pretty much as simple as that. As you just put it in front of them, and they can work through the puzzles themselves. They start easy enough that that anybody can get going right away.
Yeah,
okay,
there's
great.
definitely the collaborative piece to it as well. As Paul mentioned, being able to have the book available, I think librarians and teachers can easily just step in with their students, walk through it, and see being able to set it up properly and let it go. So I haven't had a chance myself to be able to get my hands on it just yet. I've talked through them a little bit with how it works, and I've watched the videos. But just being able to see that, you can kind of watch the logic progress through each puzzle as well. And as you watch each video in order, you kind of start to see how it works on your own too.
Okay, great. Thank you. And Paul, Alyssa, since you've had the most hands-on with the Turing Tumble, do you find the pieces get lost easily? I know, Alyssa, you mentioned marbles rolling around, and I know, having had marbles in my own house, you find them underneath everything. But how can teachers help contain the pieces?
So when we did the Kickstarter, we hadn't had packaging made yet. And a lot of our backers were teachers. And that was one of the things they said is, how can we, make this so that we don't lose parts? And somebody had the idea of making packaging that has an individual place for each part so that when they put it away, you can tell if a part's missing right away because, there'll be an empty slot there for a part. So we did that. We made a package that has an individual slot for each part, and it's clear once you put it away what's missing. The little balls, those are the most likely part probably to find in a corner in your room on the floor somewhere. But there's extras in there. You don't need all the balls, so it shouldn't be too much of a problem. We also, you can get more balls too. So if you don't have to buy a whole game to get more balls.
And that's also one of those great things that you can 3D print as well. So as you notice pieces start to get lost, you can just 3D print them in batch.
Oh, yeah. Yeah, that's a good point.
Yes, the ease of 3D printing. Fantastic. And several attendees are, one says, I'm sold. How do I go about placing an order? And a few other are asking where we can purchase it. And I think this might be a good time for me to push out the URL where you can go ahead and pre-order this. Rhea, would you like to speak a little bit more to that while I work on getting that URL out to attendees?
Sure. So the Turing Tumble is going to hit the retail market. It has an MSRP of $69.95, so only $70. And if you pre-order now through TLC, you can also receive bulk discounts as well. Give us a call and we can talk through that, especially like for the library districts and the school districts that want to buy thousands of Turing Tumbles for everybody, which I think everyone should. Definitely give us a call and we can figure out how to get better pricing for you as well.
Okay, thank you. And let's see, I have another question. Jenny from Harrison Public Library is asking, what kind of library programs have been offered so far? I think Rhea,
so far
can you address that one, or Alyssa and Paul?
I'll go first. This is Alyssa. So we only have our prototype so far. So we have mostly used it in rotation of a STEM program in a school or a STEM program for the library and community where we're only getting a couple kids at a time that come to our station. We have a library chain in Minnesota that we're a part of, and they're excited to use it in an after-school STEM program that they have, and they would use it both as a one-time thing, and then they're also looking at developing it for a 4 to 6 week, once a week program for the kids.
And as I mentioned earlier, I think that this would make a fairly good passive program as well to be able to have in your libraries, especially if you don't have a full makerspace. It could be a pop-up station that you can bring in, have the book available, maybe set up the first puzzle, or have a couple of different Turing Tumble boards with multiple puzzles ready to go so that as users come up, they can click into place and figure out and solve the puzzles and, go on with their day.
Okay, and I know, Paul and Alyssa, you mentioned having access to the CAD files. If someone were to get a Turing Tumble, and if you could just refresh the memory, where can we get the CAD files for 3D printing? Is that offered on the website, or is it part of the hard materials that they would get?
Yeah, so the way we have it right now is you can get a $15 virtual pack, and that gives you the CAD files. And then also on the community forums, people have made some modifications to them, and they've uploaded some new parts. So yeah, either place. I think I'm not sure if you can find them all on the community forums, but you can certainly find them if you get the virtual pack.
Okay, great. And Paul, Alyssa, this one would be for you as well. I know you kind of mentioned about, kind of as your roadmap, move forward about adding some more puzzles. Brianna from Siouxland Libraries is asking, do you plan to have more puzzles made? And maybe you could give us a little bit of a hint as to what you might have in mind.
Yeah, sure. So what we're thinking is to offer more puzzles that sort of practice puzzles. We were thinking of, well, our plan is to make sort of a practice book that would be downloadable online that would give people more practice doing similar puzzles to those that are in the book. So that if, sometimes a puzzle will take a little bit of a leap of imagination to figure out how to do something. And if that leap just isn't coming to them, they could, go to a particular page in the practice book and, try a few puzzles that maybe, get them there a little easier. So the puzzles won't probably be new concepts. They'll be more, just more practice with the concepts that are in the existing book.
Okay, gotcha. And Donna from LaSalle Public Library has a comment and a question. She's giving a good tip here. In a public library setting, marbles running loose are a hazard for little toddlers who may also be using the space. And she recommends some of our other games devices have been corralled by lining a Jelly Roll baking pan with a rubber shelf liner. That's a great tip.
I love that idea.
Keep things in their place. And she also asked the question, can the virtual pieces be printed on a MakerBot replicator 5th generation? That's an awful technical question I will give to Paul and Alyssa.
Yeah, so I think MakerBot would have a build platform that is probably too small to print the whole board at once, but you can use the parts where that person broke up the board into smaller parts, and I'm pretty sure that you could print them all on a MakerBot replicator.
And Donna, I would also like to add that my grandma's getting a copy of Turing Tumble, and she was already concerned about the marbles rolling all over and decided that a Jelly Roll pan would do the trick.
Good solution. Yeah, and I should tell you too. So the right now, trying to print it on like a MakerBot replicator, it'll be a little bit of a challenge. As 3D printing almost anything is, on home 3D printers. So it'll take a little bit of, practice and trials to get it right. But it's just something to be aware of. It'll be a challenge, kind of I think a fun challenge.
Okay, great. And yeah, I love the Jelly Roll pan to the rescue. Paul and Alyssa, this one's for you too. The graphic novel is a great companion for Turing. Will that become a series?
That's a great idea. You'll have to see where the story ends.
Okay, great. Thanks for leaving us on the edge of our seat there.
Don't fall off.
We do have a few more questions, and attendees, if you have any questions, please feel free to send them in. We do still have a little bit of time. I hope you see the URL up on your screen there. This is where you can pre-order your own Turing Tumble. And speaking of that, one attendee is asking about a release date, and I know that when things are often in development and production, that might not have a solid answer, but can you speak to that at all, Paul and Alyssa?
Yeah. So we're getting really close. We've been working with a manufacturer for the last 3 months or so, and it's actually longer than that. But we've had these injection molds, and we've been making improvements. And just this morning, last night, we talked to our manufacturer, and it looks like we're about a week away from having everything done. And then we'll be in production, and by May we should have everything in stock.
And I do want to add to that we are taking pre-orders now as well.
Yeah, that's right. Yep.
Yeah, get them while they're hot, before they're hot. um, and kind of getting back to the topic of types of 3D printers, Dan from Marion County Public Library is asking if you have any experience with or know about the compatibility with printing on a Lowellsbot TAS6 3D printer. I hope I said that correctly.
I don't know that one. Yeah, what I've been printing mostly on, I guess I started with a Form 1, and then more recently have used Monoprice Select Mini. And the Monoprice Select Mini has a pretty small platform, and so you do have to split up the board into smaller parts. So I'm not sure what size the build platform is on that Lowellsbot, but that's kind of the bigger the platform, the easier it is.
Okay, and I have another question. Jenny from Harrison Public Library is asking, does the puzzle book tell students how the puzzles link to computer programming concepts? And I have a follow-up question, but I'll let you handle that one first.
Yeah, that's a great question. So what we try to do in the book is to keep the terminology out of it. The concepts are all there, so the students are learning how to build logic gates, how to build all sorts of the fundamental components of computer processors. The idea being that we want the game to focus on being addictive, being something that they want to come back to, and in some sort of class, in a computer science class, then when they hit those concepts, they can put a name to it. They'll be well aware of the concept after playing the game, and they'll understand it, but they may not have the term to associate with it. So when they actually hit those terms later on, they'll be like, oh yeah, I get that. That's what we were aiming for with this. So it's not heavy on reading. It's very much focusing on the logic puzzles and the game part of it.
Okay, great. And I think I know the answer to this question, but I'll let you handle it, and maybe you have a little more follow-up or detail. Jenny's asking, too, do the puzzles build from easiest ones to the harder ones progressively?
Yeah, they do. Yep. So they start out at a level that really anybody can totally get right away. You saw that first puzzle where you just make a path from the top to the bottom. That is the first puzzle, and then they slowly get more difficult. When you get up to about halfway through the puzzles, they get more difficult. When you get to the last 20 puzzles, they get pretty difficult. I think that most adults would find them to be a pretty good challenge. And the last maybe 5 to 10 puzzles, those are really hard. So I think that adults will find them to be a challenge and to be pretty fun. And one thing that's been interesting to us, I think, is when we've had adults play and when we've had kids play, even when we've had adults who are computer programmers for a living, we found the speed that they move through isn't really that much different. It seems like it's sort of kids and adults are sort of on the same playing field, which is really interesting to me. I didn't expect that at all. So, yeah, they start easy and then they get difficult, and there's a very wide range of difficulty.
Okay, fantastic. And audience, I'm sorry, I thought I threw up the URL slide. It was showing it was live for me, but I checked out the audience view and it's just not there. So I have sent it through the Q&A, the link for pre-ordering or checking it out and learning more about the Turing Tumble. So hopefully you get that. Apologies. Kathy is asking, if you have a STEM club that meets once or twice a month, can they use the Turing Tumble, or would you recommend more of a passive program?
So I think for this one, it does make sense to, realistically, you could do either one. If you do the STEM group that meets a couple times a month and you use the Turing Tumble as an active part of that, I'd recommend maybe doing it as a STEM station, and then that way they can go work on that and they can do other STEM categories as well. And then that way, if you only have one or two Turing Tumbles, you can get two people working on one board at a time, and then that way they can move at their own pace as well. And that actually might be really good for a recurring program as well too, because each time they meet, they can learn a little bit more about the project and learn a little bit more about computer science. And then if you do it as a passive one, I think one of the downside of that is that if they're not moving at the same pace, you might only have your passive program set up as level 1 or level 2 on the boards, and it doesn't really progress beyond that. But if they do know about the Turing Tumble and they've used it before in their STEM clubs, and then they see it as a passive one, they can easily come up and just set up the board how they need it to be set up in order to get to the level that they're at.
I'd like to add something too to that. Rhea answered that perfectly. With our boys, when they've played it, when they come back to it, maybe after a couple of weeks of letting it sit, I've just encouraged them to go back and redo one or two puzzles, just to enter in again to the logic that they had just learned so that they can use those concepts to do the next puzzle.
And speaking of doing the next puzzle, one attendee is asking, and I'm sure this answer probably spans the gambit, but how long does it take an average user to complete all 60 puzzles? Paul, Alyssa, what do you think?
It's a great question.
Oh, man, it's I think it really depends on the user. Geez, what would you say? It would be probably, I would guess, over 20 hours.
Yeah, definitely over 20 hours. When I was working through the puzzle book, I was able to do about 5 a day I think I did about 5 a day for the first 4 days. And then I slowed down to about 1 a day. And I'm not average because I don't have a computer or a lot of logic background. I haven't done a ton with logic puzzles, so I'm a little slower maybe than my boys. They're a lot faster than I am.
I'm sure too. It depends on the personality of the kiddo, right? Because you have those ones who, once they get going and started on a puzzle, they can't stop until they finish. It's like more.
Yeah. We had some friends try it, and the wife actually brought the game back to me and said, "You need to take this back because Mike isn't getting any sleep anymore."
Mike is her husband.
And Mike is her husband, yes, not a kid.
Oh my God, that's brilliant.
So even at 20 hours or whatever you think that the average person takes to do it, because it's so interactive and so fun, you really get a lot of time for how much you spend for it. I think that that's a good ratio to represent.
That sounds good. Tanya from Southern Lehigh Public Library is saying that she's thinking that they would probably set theirs up as a kit for patrons to check out and take home. Rhea, what do you think about that model?
I think that makes a lot of sense. The game comes in a nice box. It's portable, and I think that would work really well. And especially if you're worried about missing pieces, I think the 3D printing element makes that a more of an in-house experience. So if you get your puzzles back and you're missing, 5 blue balls or a couple of ramps, you can easily reprint those and even set that up if you have your 3D printer on display in your library. That'll also encourage the circulation as well, because as people see you 3D printing the pieces, it's a conversation piece to start and say, hey, we also have this Turing Tumble that you can check out. So I think that would make a lot of sense, especially because it all fits in one box. And Paul and Alyssa have done an amazing job on getting it to do that. Watching the Kickstarter campaign, they've progressed a lot in where it came from, and one of the things I like is that when you pull out the board, it has these little thumb holes, so it makes it so you can pull out the board easier, but it also provides kind of a seal for everything below, so the little the ramps and the marbles don't get lost within the box, but it's all compact. So yeah, I think that does make a lot of sense to make those circulating.
Okay, great. And we do just have a few more minutes. Before I ask the last final questions, audience members, I would like to remind you to download today's copy of the slides and your CE certificate and the Makerspace brochure sooner rather than later. In about 4 minutes, when I press stop, you'll no longer be able to access that folder, so make sure to grab those items before we wrap up today. Paul, I will ask you this one. Are there multiple solutions to each puzzle?
Oh, I was hoping you'd ask that one. Yes, there are. So for a lot of the puzzles, there's not. There's just there's like one solution that'll work. But when you get to, maybe halfway through, then there are a lot of puzzles where there are many, many, many solutions. And I think that's one thing that sort of sets this apart too, is that you come up with a solution and you really have to. So, okay, let me back up. So a lot of sort of logic puzzle games out there, there's one solution and you kind of get there by trial and error. And, you try this, you try this, you try this, and eventually you sort of arrive at the solution. This is very different from that. This, you're given an objective and you really can't just stick parts on the board and hope it works. You have to come up with a plan first, or you have to come up with an algorithm for how you're going to solve it first. And I think that process of coming up with an algorithm or some kind of a plan of how you're going to attack this problem is something that's extremely valuable for kids to be exposed to. It really is what, programming is about at its core. And I think that it's such a valuable thing to begin to. Anyway, so there's lots of solutions to the problems, and on the community site, I've put up all the solutions that I came up with to each problem, and some other people have already uploaded some of the solutions that they've come up with to some of the problems. They haven't even gotten the game yet, but they've seen the booklet, and so they've uploaded some solutions they came up with. So, yes. So, thank you for asking that question.
And let's see. Was it this one or the next one? Is this where you can find
the next slide?
The next one that has with the forum. Okay, great. Another attendee asked about a forum space. So if you download the copy of the slides, you can have that URL there at the ready and join in the fun conversation. Let's see.
We also have a Facebook. Oh, I was going to say we also have a Facebook page. I noticed that question come up, but it's not a place where people are talking about their 3D designs. It's more of an update on. We'll update it when we get a new prototype in and things like that.
Okay, and I'm sure that's easily searchable on Facebook. So if you are a Facebook fan, go jump on there so you can stay on top of what's coming out of Turing Tumble. And it looks like a couple attendees may have joined just a little bit late and kind of missed where the name Turing Tumble came from, and being a fan of Alan Turing myself. Paul, if you wouldn't mind, just give that quick overview one more time.
Yeah. So it's sort of a tribute to Alan Turing. Alan Turing, he really was a visionary in computer science and started building computers before other people, even thought about these things. He was a central part of the British group that was cracking codes during World War II, and their group, by cracking these codes that the Germans were using to send information to their ships, probably shortened the war by at least a couple years. It was a huge contribution, and in order to do that, they had to build these computers, and they built some of the very first computers. And then after the war, he continued his work and built some of the very first electronic computers. And a lot of the advancements that he made are still in computers today. He he really advanced the field of computer science from virtually nothing to you know, well, a long way.
And I think that's an inspiring little tidbit to end on. We have pretty much reached the top of the hour. This is a link on this slide here to the pre-order URL. If you have any other questions or would like some more information, you can shoot an email to Mike Willis at TLC. That's his email right there. Please, if you haven't done so already, visit that green resources folder to get your goodies before I press stop, and you can no longer access your certificate, the slides, which have some really great URL resources and information, as well as TLC's Makerspace brochure. I would like to sincerely thank our presenters today for really giving us a glimpse into a really new way to approach technology without using, an internet connection. This is really great, and congratulations on your on moving forward. And I hope that May is a very exciting month for you. Thank you to everyone for attending today, and of course to TLC and Library Journal. This webcast will be archived, and we'll send you an email to let you know when it's available, usually in about 24 hours or so. You can find this webcast and all other archived and upcoming webcasts at libraryjournal.com. Thanks again for joining us today, and I hope to see you next time.